Hi guys. Today we're going to be finishing up our Notes and Expiration 2. So you need this packet. This packet was the packet that we had started on Tuesday when we were looking at the potential roots, potential zeros, potential x-intercepts, also the potential max and mins, what those are, what they look like, and the y-intercept. So figuring out what that is and how many we have of those from a polynomial. There's one last thing that we can figure out from a polynomial without a graph, and that is end behavior. So we're going to be filling in the meaningful notes section of expiration 2. So you need to flip to that. And then we are going to do some practice problems together. And then you guys will practice on your own. So for end behavior, first we're going to talk about what that is. So end behavior is describing the behavior of the ends of the graph, which is just the arrows. So are the arrows going up or down on the left side and the right side? So we're going to add that into our notes. So end behavior describes the direction of our ends of the graph, which are the arrows. Okay, so anytime that we do end behavior, one thing that you're always going to be given is this template right here. You'll get this on practices, you'll get this on tests, and we need to understand what this means. And so, how we read it is the first line is as x approaches positive infinity, y approaches something. And so, we're going to be filling this blank in. And then the second line is as x approaches negative infinity, y approaches something. And so, what this means, if we think about our x values and our x axis, if x is approaching or going towards positive infinity, all of the positive x values are the right side of the graph. So, the first line is the right side of the graph can either go up or down. And then the second line is the left side of the graph, and the arrow can either go up or down. And I know it's the left side because x approaches negative infinity, and all of the negative x values are on the left side of the graph. So we're going to go ahead and label that. So this right here is the right side, and the second line is the left side. Okay, so this is something you'll always be given, but we need to know how to fill in these blanks. So to fill in the blanks, we need to look at two things. We have two steps that we need to follow. So over here, we're going to do our different steps. So the first thing that we need to look at is we need to look at our leading coefficient. Okay, so our leading coefficient again is the number in front of the term with the highest exponent. And so when we look at our leading coefficient, we need to look and see if our leading coefficient is positive or if it is negative. So if our leading coefficient, so LC, leading coefficient, if our leading coefficient is positive, then the right side goes up. So the right side of our graph is going to go up because our leading coefficient is positive. And so what that means is we can fill in the first blank with a positive infinity. Okay, so excuse my bad infinity sign. It's like a sideways 8. So if our leading coefficient is positive, then we put positive infinity in the first blank. So then if our leading coefficient is negative, that means the right side goes down. If the right side is going down, that means we put a negative infinity in the first blank. So if our leading coefficient is positive, this is positive infinity. If our leading coefficient is negative, then this is negative infinity. So it's always going to match your leading coefficient for the first blank. The second thing that we need to look at is we need to look at our degree. And our degree is always going to be positive. We're always going to have positive exponents in polynomials. So instead of looking at positive or negative, we need to look and see if it's even or odd. So if our degree is even, that means the same. So that means whatever we put in the first blank, the second blank has to be the same. They have to match. They have to be the same for both of these blanks. And then if our degree is odd, that means odd. So odd and opposite. Oops, that means opposite. Sorry, guys. So odd is opposite, which means whatever's in the first blank, to know what goes in the second blank, it has to be the opposite. So if we had a positive infinity, that means our second blank would be negative. If we had a negative infinity, that means our second blank would be positive. Okay, so we are going to do some examples together because it might seem like a lot now, but we're just filling in these two blanks. And I think once we do a couple examples, it's going to make a little bit more sense. We just have to remember that the first thing we look at is leading coefficient, and the second thing we look at is degree. Okay, so make sure you have these notes written down, and then you can go ahead and flip your page over to the guided practice portion, and we're going to do a few of those. So in the guided practice, we have to look at two things. So the first thing we need to look at is our leading coefficient. And I like to write it on the side because that is going to help me remember. So whenever we look at polynomials, we first have to make sure that they are in standard form. So in order of the highest exponent down to the smallest. So looking at this polynomial that we are given, it is already in standard form. So we have the highest exponent of 8, and then 5, and then 3, and then we end up having a constant. We don't have any like terms that we can combine, so it is in standard form. So I can identify my leading coefficient, and I'm looking to see if it's positive or negative. So my leading coefficient in this one is a positive 6. So that means my leading coefficient is positive, which tells me my first line here is going to be a positive infinity. So that means the right side of my graph is going up. So my leading coefficient was positive. I put positive infinity here. Those have to match. The second thing I look at is my degree. And my degree can either be even or odd. And remember, our degree is the largest exponent. So my degree for this one is 8. 8 is even. Okay, so even, if we look back at the meaningful notes section, means the same. So that means this blank has to be the same as what I already wrote up here. And so because I wrote a positive infinity, it has to match that. It has to be exactly the same. So this one is also going to be a positive infinity. And so what this tells me is the right side of my graph is going up, and the left side of my graph is also going up. So both arrows are going up. We're going to do this one over here on the right-hand side. Again, we want to make sure it is in standard form. So looking at this polynomial, it is in standard form. We have largest exponent down to the smallest. We don't have any like terms to combine. So again, I want to identify a couple things. I want to start with my leading coefficient. And how I remember I look at my leading coefficient first is because it has the word leading in it. And leading means like in front or first. So I always look at that first. My leading coefficient is negative. I have a negative out in front. So because my leading coefficient is negative, this is also negative. So I put negative infinity. Then I look at my degree. My degree for this one is 5, and 5 is an odd number. So my degree is odd. Odd means opposite. So the opposite of negative infinity, because that's what I already wrote on the top one, is positive infinity. So they have to be opposite signs. And so that's how I know this one has to be positive. It has to be opposite of what I wrote up here. So what this tells me is the right side of my graph is going down. The left side of my graph is going up. We're going to finish these last two here. I know there's more examples underneath. But for this one, again, I look at the same two things. So the first thing is my leading coefficient. So my leading coefficient for this one is also positive. It is in standard form. And my degree for this one is 3, and 3 is odd. Okay, so I found the things I needed to. So if my leading coefficient is positive, that means this first blank is positive. So positive infinity. And then my degree is odd. Odd means opposite. So I do the opposite of what I already wrote. So then I put negative infinity for my second blank. And then the last example, again, I still like to label them. So my leading coefficient for this one is -2. So -2 is out in front. So my leading coefficient is negative. And yes, this is in standard form. My degree for this is 12. And 12 is an even number. It is divisible by 2, so it's even. So my leading coefficient is negative, which means the first blank has to be negative. So negative infinity. My degree is even. Even means the same. So I fill in the second blank so it's the same as the first blank. And then I did my end behavior. Okay, so you guys are going to get a practice on your own. I do want to go through one more example from the other day to kind of combine everything. So in your packet, flip over to the independent practice section. So we just did a couple of the guided. I want to go through one of these. So there's 4 at the top. I want to go through this first one right here. So the top left. So we are doing end behavior. Again, you're given the template. We're just filling in the blanks. And then the potential zeros, max and mins, and the y-intercept. That's what we did on Tuesday. Okay, so we're going to do those. I am going to start with end behavior. So for end behavior, we want to look at our leading coefficient. And this is in standard form. So our leading coefficient is out in front, which is -4. So because it's negative, this also has to be negative. Then I look at my degree. My degree is my highest exponent, which is 8. 8 is even. Even means the same, so I also do a negative infinity. So these two blanks have to be the same. So now we can answer the 3 questions at the bottom. So my number of potential zeros is the same thing as the potential roots or the potential x-intercepts. And for that, I look at my degree, and my degree is 8, so I know I have 8 potential zeros. For my potential max or mins, that is 1 less than my degree. So if I have 8 potential zeros, that means I have 7 potential max or mins. And then my y-intercept, I look at my constant. And I do want to make sure that I write my constant as a point. So it's going to be 0, comma, and my constant is a positive 1. So the constant is a number without the variable. So I write it as 0, comma, 1.